before we get into the meat of algebra, I wanted to give you a quote from one of the greatest minds in human history, Galileo Galilei, because I think this quote encapsulates the true point of algebra and really mathematics in general. He said, "Philosophy is written in that great book which ever lies before our eyes. I mean the universe. But we cannot understand it if we do not first learn the language and grasp the symbols in which it is written. This book is written in the mathematical language, without which one wanders in vain through a dark labyrinth." So very dramatic, but very deep. And this really is the point of mathematics. And what we'll see as we start getting deeper into algebra is that we're going to start abstracting things. And we're going to start getting to core ideas that start explaining really how the universe is structured. Sure, these ideas can be applied to things like economics and finance and physics and chemistry. But at their core, they're the same idea. And so they're even more fundamental, more pure than any one of those applications.
And to see what I mean by getting down to the root idea, let's go with we started with the very grand, the philosophy of the universe is written in mathematics, but let's start with a very concrete, simple idea. But we'll keep abstracting and we'll see how the same idea connects across many domains in our universe. So let's just say we're at a store and we're going to buy something, and there's a sale. The sale says that it is 30% off. 30% off. And I'm interested, I don't shop at my too fancy store. So let's say I'm interested in the pants before the sale is not pretty much. So I'm y is equal to force. We could let y is equal to force.
And m is equal to acceleration. We could say x is equal to acceleration. Well, then the famous force is equal to mass times acceleration can be rewritten, and it's really the same exact idea as y, which we've defined as force, can be equal to mass, which we're going to use a symbol p, which is equal to p times acceleration. We're just going to happen to use the letter x here, times x. Well, this is the exact same equation. This is the exact same equation. We can see that we can take this equation and it can apply to things in economics, or it can apply to things in finance, or it can apply to things in computer science or logic or electrical engineering or anything, accounting. I mean, there's an infinite number of applications of this one equation. And what's neat about mathematics and what's neat about algebra in particular is we can focus on this abstraction. We can focus on the abstract here, and we can manipulate the abstract here. And what we discover from these ideas, from these manipulations, can then go and be reapplied to all of all of these other applications, to all of them. And even neater, it's kind of telling us the true structure of the universe if you were to strip away all of these human definitions and all of these human applications. So for example, we could say, look, if y is equal to p times x, so literally if someone said, hey, this is y, and someone says on the other hand, they say, I have p times x, I could say, well, you have the same thing in both of your hands. And if you were to divide one of them by a number, and if you wanted them to still be equal, you would divide the other one by that number. So for example, let's say we know that y is equal to p times x. What if you wanted to have them both be equal, and you say, well, what is y divided by x is going to be equal to? Well, y was equal to p times x, so y divided by x is going to be the same thing as p times x divided by x. But now this is interesting, because p times x divided by x, well, if you multiply by something and then divide by that something, it's just the same. You're going to get your original number. If you multiply by 5 and divide by 5, you're just going to start with p, or whatever this number is. So those would cancel out. But we were able to manipulate the abstraction here and get y over x is equal to p. And let me make that x green. Y over x is equal to p. And now this has implications. This has implications for every one of these ideas. One is telling us a fundamental truth about the universe, almost devoid of any of these applications. But now we can go and take them back to any place that we applied. And what the really interesting thing is we're going to find there are an infinite number of applications. And we don't even know, frankly, most of them. We're going to discover new ones for them in 1,000 years. And so hopefully this gives you a sense for why Galileo said what he said about really mathematics is really the language with which we can understand the philosophy of the universe. And that's why people tell us that if a completely alien life form were to ever contact humans, mathematics would probably be our first common ground, the place that we can start to form a basis that we can start to communicate from.